Greetings there, physics fans, and I figured I'd give you a little discussion on the wonders and the properties of salts. And salts have three basic properties that we're quite interested in. One, they have high melting points and boiling points. High melting points and boiling points. Two, brittle solids. Now this means that salts don't, well, bend very well. If you hit them with a hammer, they will break, they shatter. They don't bend, they don't dent, and there's a reason for that. Thirdly, salts don't conduct electricity in their solid form. However, if you'd like to get them to conduct electricity, we can melt them or dissolve in water. So these are all very true. Now let's see if we can't talk about why. And you'll notice on the top left and top right, we have some crystal lattices that I have drawn here for you, okay? Now, one is an entire crystal lattice, whereas the other is in fact one repeating part of the crystal lattice. So I'm going to draw a picture of the crystal lattice in only two dimensions, whereas we could have both positive and negative charges. This is kind of how I did it in my little Mickey Mouse drawing on the board, right? There are some computer animated versions that are far better than this. But my two dimension also has its uses. So I'm going to draw it in. Now you're going to notice something shown three-dimensionally above this, but give me one more moment here. And so here I am drawing the positive and negative repeating pattern. Now up top, they're showing us, well, bluish purple sodiums. Notice how they're small and positive. And green chlorines, which are the negatives that are larger. And so we have our top version on the left, and this top left version is showing us something that is somewhat opaque, right? But here we have our negatives and our positives, and they repeat over and over. Now, when you look at your unit cell over here, look at the sodium in the center. It, in fact, has 1, 2, 3, 4, and then in front and back, it has 6 total ions surrounding it. And so any one of these is going to have 6 total ions surrounding it, and therefore, it's not just one positive and one negative attracting, but it is 6 positives and 6 negatives attracting. And that's really important. That makes the crystal much stronger than it would otherwise be if it was just a positive and negative attracting one another. And so this makes the melting point extremely high. As far as conducting electricity goes, or better yet, as far as, if I was to go in order, as far as being malleable or ductile, if a force was to be exerted on this salt, what we could do is shift this entire line of ions over. And if I did so, I could cause the positives to line up and the negatives to line up. So I might have something that looks like this in one line, where I might have positive to positive and negative to negative. And if that was the case, negatives and positives would repel one another. And if they repelled each other, that would cause the salt to fall apart, and therefore it would not bend in any way, shape, or form. On the other last hand, as far as conducting electricity goes, if the salt's supposed to try to conduct electricity, well, any of these ions, be it a chloride ion here, has an overall -1 charge. The sodium ions have an overall +1 charge. If they were to accept any electrons, the -1 charge would become a different charge altogether, or the positive charge would change altogether. And well, since this ratio of ions is set up according to charge, it resists this change by holding on to its electrons tightly and keeps electrons from flowing in or out of the salt. How can we make a salt conduct electricity? If we were to dissolve it in water or to melt the salt. In either situation, we'd be breaking apart the crystal lattice. And by breaking apart the crystal lattice, we therefore then could allow the ions to change in charge briefly. Hope that this discussion was fruitful, helpful, and good luck.